Welcome to Scanner School. There is a very simple, easy, and affordable way that you can improve the sensitivity of your scanner. By sensitivity, what are we talking about? Its ability to bring in signal. And sometimes, by adding this one little magic device, you can bring in even more signal into your scanner. And I'm going to tell you how right now on Scanner School.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
So welcome to Scanner School, where we teach you everything that you need to know about the scanner radio hobby. My name is Phil Lichtenberger, and my amateur radio call sign is W2LIE. I want to thank you for joining us today for session number 34 of the Scanner School podcast. All the session and show notes for everything we talk about today can be found online on our website at scannerschool.com/session 34. And again, I want to invite you also to join our weekly newsletter. We kind of recap what we talked about on the podcast, plus other things that are going on outside of the podcast. Because right now I've actually started calling this the Scanner School Project, because we have a little bit more going on than just podcasting at this point. So if you want to be kept in a loop, just go to scannerschool.com, and on the right-hand side, you'll see a form that you can fill out, and that'll put you onto our email list. Now, again, we will never spam or sell your list to anybody. This is our internal list, and we just use that to let you know what's going on here at Scanner School. But before we get into today's podcast, before we start talking about filters, yes, filters are the little magic device. I want to remind you that today's podcast is sponsored by East Coast Pagers. Now, East Coast Pagers is one of my many websites, and we are a Unication, Apollo, and Swiss phone pager dealer serving the North American market. So from those old one-way PogSag flex pagers that, doctors and certain individuals used to wear, yes, they are still very popular with fire departments and medical staff, and also voice pagers that are very popular with fire departments. We specialize in the Apollo, the Swiss phone, and the Unication product line for both digital, when I say digital, I mean the PogSag and Flex, and the voice pagers, the G1, the G4, the G5, P25 pagers, the Swiss phone S-Quad voice, and the new Swiss phone S-Quad 360. Now, there are rebates going on right now on the Unication and Swiss phone products. So if you go to eastcoastpagers.com/scannerschool, not only will you see what the current promotions are, but you'll have something a little bit extra in your shopping cart, courtesy of yours truly. So again, eastcoastpagers.com/scannerschool. All right, guys, now that we have put that behind us, let's talk about filters. A lot of what it is that we are talking about today, I pulled off of a website called radioelectronics.com. I want to say a lot of it. I'm just going to say a lot of the technical stuff, a lot of the definitions. I want to make sure I got them right for you guys. So that's what I'm going to be reading off their website. And I will have a link to that exact page on radioelectronics.com in the session notes at scannerschool.com/session 34. So what exactly is a filter? Well, as the name implies, a filter will either allow or reject a certain set of frequencies from passing through that device and onto the rest of your antenna's network. So what's the rest of the antenna's network? It could be the radio it's plugged into, or it could be anything else beyond where you've set up that filter. And we'll talk about positioning of the filter later on in this session. But that's basically what a filter is. It filters out, either rejects or allows to pass a certain bank of frequencies. And there's certain number of terms that you need to be aware of when you talk about filters. We're going to go through just a couple of them. We don't need to know all of them because we're not getting into building designing or anything else. We're just getting to the basic, simple filters that you can buy for the scanner radio market. So one of the main terms would be a band pass. The band pass are the frequencies that are allowed to pass through the filter with a minimal change in attenuation, because sometimes there is an insertion loss when it comes to putting a filter in your network. So remember that. Sometimes you will get a loss. Sometimes it's a minimal loss. Sometimes it could be a little bit of a loss, but that will be on the spec sheet. you have to know the ripple band. Now, the ripple band is kind of like when you drop a pebble in the water and the water kind of ripples out a little bit. Not saying that it radiates out from center, but you can see a ripple effect in the water. Now, that is a characteristic of the filter itself. The filter may not be a flat top design. It may vary up and down slightly in attenuation through the band that it's allowed to pass, or the band pass range of the filter. So you'll see that basically on the plot of the filter you're going to purchase, or if you're going to run a bench test on a plot using your oscilloscope or something like that. You also need to know the cutoff frequency. The cutoff frequency is the response of the filter where the frequency has now dropped 3 dB below the frequency range of the filter. So where, if you look at a chart, basically what happens on a filter is you have a range where it's allowed to pass through the filter, and then it starts to fall off, kind of like a car going off a cliff. When that car goes off the cliff and you're at the 3 dB point, which is half power, by the way, that becomes the cutoff frequency. As that car is flying off the cliff, where it hits, I guess, the bottom of the cliff, let's call that the rejection point. That's the stop band. That's basically the point of the filter where nothing else is going to get through. And this will be defined also in the specs as a decibel format, or in dB. So again, you've got the car driving on the road, right? That is your band pass. The car goes off the cliff and starts to descend. That's your cutoff frequency. As the car is soaring into the air, and before it hits the stop band, that would be the skirt. That's the trajectory of the car going through the air as it is getting to this point where it's going to impact the ground. That's what you would call the skirt. The skirt is basically the slope between the cutoff. Again, that's the cutoff is where the frequency response is dropped to 3 dB, and the band rejection, which is basically where the filter just stops allowing anything to pass through the filter. So we've basically got really what passes through, where the 3 dB point is. Again, that is the cutoff. The stop band would be the ground, where nothing else is going to get through. And the skirt of the filter is basically the point or path between the cutoff frequency and the stop band. All right, so now there's a couple of different filters that we need to be aware of when we're either putting one into our scanner station or just going out and shopping for them. We have a low-pass filter. Now, a low-pass filter allows frequencies below the cutoff frequency to pass through the filter. So if your cutoff frequency was, say, 50 megahertz, a low-pass filter will allow anything below 50 megahertz to pass through. Just the opposite, you have a high-pass filter. Now, a high-pass filter will allow anything above the cutoff frequency through the filter. So again, if you had a cutoff frequency of 50 megahertz and you were using a high-pass filter, everything above 50 megahertz would pass through the filter. And of course, technically anything below 50 megahertz would then not be passed through the filter or be rejected. You have a band pass filter. This is a range of frequencies that will allow to be passed through the filter. So you have a low and a high pass filter basically put together, which rejects everything lower than the cutoff and rejects everything higher than the cutoff. But everything in the middle is allowed to pass through the filter. And now the complete opposite of a band pass filter is a band reject filter, where everything below the lower cutoff is allowed through. Everything between the lower and the upper cutoff is rejected, and everything beyond the upper cutoff is then passed through again. So why would you pick one of these four filters over another? Well, I want to tell you a little story about a coworker of mine. Now, a coworker of mine, he lives in a building. He's 3 stories up, and the side of the building that he lives on actually is adjacent to a cell site. Now, here in the States, the cell sites operate on 700, 800, 1900, and I guess the AWS spectrum, which would be 21, 2200, 1700, and also WCS 2300. We're only worried right now about the 800 band because the 800 cellular band is just adjacent to the 800 public safety band. And my coworker's radio wouldn't work for anything on trunking. He couldn't receive anything when it came to 800 megahertz. And the reason why is because his radio was being overloaded by the cell site that was next door. Now, keep in mind, my coworker was in a third story where he's staying. The cell site across the street was just as high as his room. So he was basically getting blasted by all this RF in the 800 megahertz band. His scanner was overloaded when it came to that 800 megahertz band. What did he try to do? Well, first thing he tried to do was hit that attenuation button. And by attenuating it, he attenuated everything across the band when it came to 800 megahertz. Not even just 800, but everything else that was coming in that scanner. Yes, he could have attenuated just the trunking frequencies, but that didn't help because the band that he was trying to monitor was just being blown out of the water by the cellular site that was right next door. So what did he do? He fabricated his own band reject filter. And what this really did was it just notched out the cellular band and allowed everything else to pass through it. Once he installed his band reject filter and filtered out or just padded down all of the cell site frequencies like magic, he was able to get the neighboring county 800 megahertz system like he was sitting in the next county over. And that's because he filtered out what was interfering with his radio, what was raising his noise floor. When those frequencies from the cell site were never able to hit his scanner was basically deaf to them. They never existed. And the scanner was then able to improve its sensitivity on the 800 spectrum that he really wanted to listen to. That's why in the pre-roll, I said it's a very simple and easy way by adding a filter to improve your radio's sensitivity. So let's talk about another kind of filter, just the opposite, a band pass filter. A couple of sessions ago, we talked about an ADSB receiver. So if you want to go back and listen to that episode, you can go back to scannerschool.com/session24 when we talked with Eric Carlson from FlightAware. And we talked about a whole ADSB setup. And really what ADSB is, to really put it briefly, is that is a frequency that airplanes use to beacon out where they are. Basically, it has their tail number, their squawk identification, as well as some other information if they declare an emergency and whatnot. But really, it's got their altitude, their heading, and their speed, as well as their tail number. And you can plot them on a map. Now, in order to really improve the sensitivity of the USB dongle, that is really affordable, by the way, you can install a bandpass filter for ADSB. Now, this bandpass filter is about $35, $40 maybe, and it screws right into the USB dongle, and it only allows the frequencies from 980 to 1150 to pass through. Well, the ADSB frequency is 1090 megahertz. So that's right in the middle of the sweet spot of this bandpass filter. So why do we use the bandpass filter in the ADSB platform, and why does it work so well? Because it allows that USB dongle to only worry about what is going on in that range of frequencies, right in the sweet spot for ADSB broadcasts or ADSB identifications. You're not worried about the local UHF transmitter, the local low band site, the local paging transmitter, FM radio transmitter, even the cell site. All of that is being filtered out by the filter, and your radio only has to listen to the ADSB frequency at 1090 megahertz. So that's really two examples as to how a filter could be beneficial to your scanner radio setup. Now, just one more example of how you could use one. If you're a shortwave radio fan, you may want something that rejects everything that's above the shortwave band. Or maybe you want something that is going to filter everything that's in the medium wave band or the AM broadcast band. You don't want anything that is from the local AM transmitter site to overload your receiving side of your shortwave radio. So you're going to want something that filters out the local AM broadcast. So you can listen to something that's across the world that maybe you're not really going to be able to receive all that clear if you didn't have the filter. So these are several examples as to where filters can really come into play. Now, again, if you live close to a cell site, if you live close to a FM broadcast transmitter. There are filters out there that will reject those so that you can easily block out those frequencies. So let's talk about the placement of a filter. Now, again, it really depends on your needs. So, for example, if I have, or a great example is mine. In my multi-coupler setup, I bring my antenna in. My multi-coupler feeds several radios. Now, again, if you want to talk about multi-couplers and learn more about them, you can go back to our last week's session, scannerschool.com/session 33, where I talk about multi-couplers and what to look out for. But in my example here, on my multi-coupler, one leg feeds my ADSB receiver. I don't want all of my scanners to have a filter in place. So I just put that filter right before my ADSB receiver. Just that radio now is being filtered on those frequencies. But if I had to knock out the FM broadcast frequency range or the cellular range on all of my scanners, I would want to put the filter right at the where the multi-coupler is getting its antenna feed. This would then filter out every single radio that's running through the multi-coupler. So it really depends on where you need to put the filter. Either if it's a one-off case, you just put it right by the radios that need to be filtered or have a filter in place. But if it's your entire scanning setup, yes, you would want to put the filter before your splitter. Now, again, please listen to podcast session number 33, scannerschool.com/session 33, if you haven't listened to it and why we recommend going with a multi-coupler as opposed to going with something like a T-connector or a cable TV splitter. All right, all of that is in that podcast. So what do we want to look for when we're buying a filter? Well, first of all, you want to look at the type of connections that are on the filter. Typical filters that are made for the scanner radio community have BNC filters right on them. You want to look at the type of filter you are buying. Is it a low pass, high pass, band pass, or band reject filter? You want the right tool for the job. You're not going to use a screwdriver to take a nut off of a bolt. It's just not going to work. You want to look at the impedance level of the filter. Now, again, most filters for the scanner radio market have 50 ohms impedance because that's what the antenna and the coax and the radio are all supposed to be tuned to, is 50 ohms. So again, that's why we use LMR 400. That's why we use the right antenna, the right type of ways of splitting the signal using a multi-coupler and not a cable TV splitter or even a T-connector, okay? This is why the whole series is in play here, because we're trying to teach you how to optimize your scanner radio setup. And also, the final thing that you want to look at is the cutoff and stop band frequencies and the rejection measurements in dB of the filter. You're going to want to know where the filter is going to start cutting off when that car goes off the cliff and where it hits the wall or the floor. Those are really the measurements you want. And of course, you're also going to want to know the insertion loss of the filter. By plugging in the filter, are you going to take a 3 dB hit, or are you going to take a very minimal hit when it comes to what you're trying to accomplish here? So again, these are all values to look at when it comes time to look at filters. So if I have persuaded you to purchase a filter for your scanner radio setup, may I remind you to go to scannerschool.com/filters or scannerschool.com/filter. One or the other is going to take you over to, it's going to be an affiliate link, and it will take you to where you can purchase filters for your setup. Now, again, they are very, very affordable. And by using one of our affiliate links, that will be a way to help support the Scanner School podcast. And it comes at no additional cost to you. Again, go to scannerschool.com/filter, and that will take you to Scanner Master, who we strongly recommend when it comes to buying any scanner radio equipment. We've been a customer of theirs for the last 20 plus years, and we've also had them on the podcast as our guest. And if you're looking at making a larger purchase at Scanner Master, use coupon code SCANNERSCHOOL7. That's Scanner School with the number 7. And that will give you free shipping if you spend $200 more at Scanner Master. So again, go to scannerschools.com/filters, and that will take you right to their page where you can purchase a filter or some filters for your scanner radio setup. So again, if you're looking for other ways that you can help support the Scanner School project and the Scanner School podcast, go to scannerschool.com/support. And on that page, you will see several different ways that you can help support Scanner School, either by making purchases at Amazon, a one-time PayPal donation, we do have some merch coming. We haven't really gotten that far yet. Or also, you can become a Patreon supporter. And I want to thank our Patreon supporters this week. We have MT Bono, Kenneth Fowler, and Mark Beebe, who are continued Patreon supporters. And you can support the Scanner School podcast on Patreon for as little as $1 a month. And if you spend $5 a month or pledge $5 a month, you will get the podcast delivered to you earlier than a general public. So there is a benefit of pledging $5 a month. Again, everything we've talked about over the last few weeks is available on our resources page, scannerschool.com/resources. On there, we have options for places to make purchases, where to find more information, where to get better to read manuals, and then everything we've talked about over the last few weeks: antennas, coax, multi-couplers, lightning arresting, and today, filters. So if you're looking at building your first station, or maybe making modifications to your current setup, please go to scannerschool.com/resources. And many of the things, but not everything on the page, is an affiliate link. And if you use that page to make a purchase, now again, that's a great way to help support the Scanner School podcast and everything is that we do here at Scanner School, and it comes at no additional cost to you. All right, guys, that is it for the week. I want to thank everybody who has subscribed to us either via iTunes, Google Play, Stitcher, and now, new for this week, iHeartRadio. Yes, you can now listen to us on iHeartRadio, and a great way to do so is by using your Alexa device. So if you say, "Hey Alexa, play the Scanner School podcast on iHeartRadio," your Alexa will play this podcast. Another great option to listening to the Scanner School podcast. And if you haven't done so already, click subscribe on your smartphone. Go to scannerschool.com/subscribe to subscribe to the podcast on any of the methods that we have listed there. And if you wouldn't mind leaving us a review on iTunes, that's a great way to let other people know the benefit of listening to Scanner School. Scannerschool.com/iTunes. All right, guys, that is it for this week and filters. And we will catch you all again next Tuesday for the next session of Scanner School, where we teach you everything that you need to know about the scanner radio hobby. My name is Phil Lichtenberger, 73. Catch you again next week.
Thanks for listening to the Scanner School podcast. Be sure to visit www.scannerschool.com to access the show notes and bonus content.